11 methods, we're going to look at question 13 from exercise 5C. So we want to sketch the graph of each of the following functions, okay, and we want to state the range of each. Okay, so there's two parts. We're sketching the graph and we're finding the range. Now, if you look at part A, it says f, so that's the name of the function, such that the domain is -1 to 2, including mapped into reals with the rule of the function being f of x equals x squared. Okay, so normally, we know the graph of y equals x squared looks like that. Okay, now obviously we're drawing this in function form, so it's no longer y, it's just f of x at the top on the y-axis, and we're graphing against x. Now we've got to be careful because the domain is -1 to 2, meaning we don't want the full graph like that. We want a restricted graph. Okay, so first things first, I actually like to work out what the endpoints are. Now I know it's a standard parabola, but I need to work out when x equals -1. Oops, when x equals -1, what does y equal to, or what does f of x equals to? So in function notation, when we sub in x equals -1, you find f of -1, which equals 1 basically. X equals 2, f of 2 equals to 4. Okay, so you've got two parts to the graph, or 2 points to the graph. One is at -1, 1, and the other one is at 2, 4. Now you got to pay attention to the endpoints. Are they closed circle or open circle? You just look at the brackets to see whether it's a square bracket or a round bracket. If it's round bracket, then it doesn't include that point. If it's a square bracket, it does include that point. So here we've finished drawing the graph. Now you got to be careful because we haven't answered the question yet. Okay, because we've drawn the graph, that's great. I want to find the range. So the range is the possible y values. It's the last value, which isn't 1, okay, because the last value isn't here. It's actually here. That's the last value. It happens when there's 0. So don't always go automatically assume that the endpoints are always going to be like your lowest and highest values. Okay, in this case, clearly it's not. So your range would be between 0 to your highest value, which is 4. So 0 to 4. So let's do another one. We'll do part B. Part B, it's another quadratic. Okay, so we've got f of x equals x squared plus 2x, and we've got a limited domain. Now, because this is another quadratic, but it's not a simple quadratic, you've got to do some work to find out the x and y intercepts and so on and so forth, or the f of x intercept and the x intercepts. So x intercepts f of x equals 0, or it's the same as saying y equals 0. I'm just using the f of x term notation. Let that equal 0. Oops, let that equal 0. And what we're going to do is we're going to factorize it, because I need to use the null factor law to solve for x. X plus 2 equals 0, so x equals 0, x equals -2. Okay, so these are my x intercepts. Done. My y intercepts, we don't have any because this is like in polynomial form, and we got plus 0 there, so your y intercept's going to be 0. Okay, so before I even draw this, I need to find the turning point, because like I said, it's not necessarily a straightforward parabola that we know. So we've got to find a turning point. XTP is the average of the two x coordinates, so the average of 0, -2 is -1. YTP, the y coordinate of the turning point, you sub back in. So I'm going to sub in -1 to get my corresponding f of x value or y value. Okay. So this will become 1 minus 2. Oops, 1 minus 2. It's minus 1. Okay, so turning point's at -1, -1. Okay, I'm pretty confident I can draw the graph now, or roughly draw the graph. So we have a intercept -2 and 0. Oops, not 2, 0. And you label the axis f of x and x. And we're going to draw the curve. It's a smiley face. It's going to look something like this. Now, you've got to be mindful of the domain. You're starting at -2, so we're starting here, and we're ending at 2. So we're ending somewhere along the way there. So we've still got to find the endpoint, because it includes that value. So when x equals -2, I want to find f of -2. No, sorry, 2. When f is when x is 2, we want to find what f of 2 equals. F of 2 is 2 squared plus 2 times 2, which is 4 plus 4, which is 8. Okay, so this would be 2, 8. So in terms of my graph, I probably should make this a bit more shallow. Okay, so because that's going to be 2, 8. So this is -1, -1, and this is 2, 8. Okay, so it should be always roughly proportional. Now, so my range would be my loss value. Again, the loss value is not -2, or 0, sorry, not -2, 0. It's actually at -1. So you're going from -1 to the highest value, which is 8 for the graph. I'll do one more. We'll do C. Now, this is a standard hyperbola graph. Okay. Our y asymptote's at 0, our x asymptote's at 0, and you've got f of x and versus x. Now, we want the graph between 0 and 3, not including 0, okay? And that makes sense because 0 is an asymptote anyway, so it's... So 0 and 3 means I just want positive half of the graph, or positive part of the graph, not positive half, but positive part of the graph. So it's going to look something like this, asymptote there, and you're stopping at 3. So you've got to work out what that value is, that endpoint is. So f of 3 equals 1 on 3. So it's 3, 1 on 3. That's the endpoint. Okay. Oops. That's the endpoint. So now I've drawn the graph. We've drawn our asymptotes. This obviously goes on forever up there, but we're getting cut off at 3. So my range for this graph would be from a third, because that's my loss y value, to positive infinity, because this graph goes up forever. Okay, goes up forever. It's trying to approach that x asymptote there. So basically, that's how you approach questions like these. So hopefully that helps. So for D, I'll just quickly mention it. For D, you need to draw a complete quadratic graph, because it says reals to reals, meaning that you don't have a restricted domain because the domain is reals, but you need to find the x-intercepts, y-intercepts, and the turning point. Okay, so you have to do quite a lot of work for that one. And remember, you have to look at the turning point to determine the range. Okay, that's really important. Similar thing here, except the domain's restricted. Make sure when you're drawing the endpoints, can you see there's a curvy brackets? When you draw the endpoints, they won't be colored in circles, they'll be empty circles. So you've got to pay attention to that. So when you're actually finding the range, so let's just say that circle's not colored in, it's open circle. Your range would be from 0 to 4, but not including 4. Okay, it'll be a closed bracket. Okay. So have a go at these. They're not impossible. You just got to get used to the notation and how to sub in.